All right, so let's start. Hello, everyone. Welcome to today's webinar. Today, we are going to be talking about the next topic in Terraform. Right? So we are going to talk about Terraform modules. Right? I'm not sure if you guys were around for the first webinar for Terraform. In the first webinar of Terraform, we talked about what, why, and how for Terraform. So maybe I'll give you a bit of an overview, and then I'll go to the topic of what are Terraform modules. Okay, I'm not going to cover Terraform itself in detail. So it's a prerequisite. You guys should know Terraform already to understand modules, at least the basic working, what is the Terraform and how does it work. This is going to be the next topic. When you know Terraform, how do you use Terraform modules? Before starting, let me introduce myself. My name is Amit. I am from Bangalore, and I have around 19 years of experience. I've been in the industry for 19 years and have worked on the complete breadth of DevOps and associated tools and solutions. Right? Cloud, version control, CI/CD, containerization, configuration management, infrastructure as code, everything. Before I start, I will have to let you know about an interesting thing. So SkillUpright is now launching their DevOps practitioner training, right? And I will be the trainer there for them when they start. So there are some starting dates. These are tentative, but uh, most probable. And in this course, we are going to cover the entirety of the DevOps ecosystem, right? So we are going to start with Linux and networking basics. And then we talk a lot about DevOps, version control using Git, build tools, Jenkins, Terraform, Ansible, Docker, Kubernetes, monitoring, right? So the webinar is kind of a trailer for you on what you could expect in this certification course, right? Again, it's not a requirement for you to subscribe to the certification course for attending this webinar. The webinars are free for everyone. But if you want to get into DevOps and you want to have complete understanding of DevOps, I think this is the way to go, right? So please take a look at it. I'll drop a link for the course here in the chat. I think the cost is also mentioned here, but I suggest you reach out to the SkillUpright team on having any discussions, right, on this. So pretty good coverage. I have designed this course along with the experts at SkillUpright, and I hope I will be taking this training course as well, right? Okay, so let's get back to the discussion. So let's start with understanding what is Terraform, right? So if you have worked in the industry, every software project requires compute resources. So you need servers, right? You need databases, you need data storage, you need your maybe networks, right? And many other resources, right? And a software team, uses these resources to develop product, right? They need to write code, they need to compile, they need to package, they need to verify, validate, test, deploy. For all that, they require compute power. How do you get the compute power? Either your company buys some servers or some hardware and then provisions them to you, to the company or to the team, or you rent them from from a cloud provider like AWS, right? So either you can have a private data center, right? So you can have a big building, right? You can have a big building, and in the building you can house your servers. This is a private data center. Everything is managed by the company for you, right? It is a bit of a high upfront cost. You have to pay a lot for keeping the lights up. So the second alternative is that you go with a cloud provider like AWS or Google Cloud or Azure, right? And you get an account there. Maybe your organization can get an account or you can get an account and you create resources on demand. If you want 5 servers, you create 5 servers, right? If you want 2 databases, you create databases, right? If you need network, you create network, right? So it's up to you how you want to utilize. And when you are done with the resources, you can just get rid of them, destroy them, and you stop paying for them. So with a cloud provider, you do not have an upfront expense and you pay as you go. So you pay for infrastructure as you need it. When you don't need it, you stop it, destroy it, and you don't have to pay for it, right? So that's why providers have gained a lot of popularity and are like de facto infrastructure provider for many enterprises. And we are going to understand how in the industry teams provision their infrastructure. How do they get the servers, right? So how do you provision the infrastructure? The easiest way is you log into your AWS account like this. This is your AWS console. You log in there. You search for, let's say, EC2. So if you are not aware of AWS, EC2 is the service for virtual servers on the cloud. You can go to EC2 and you can just quickly create your virtual machines, right? So I can maybe click on this launch instance and I can choose my operating system. I can give it a name, right? I can choose the architecture. I can choose how many resources should be there in the EC2 instance or in the virtual machine. So I go with the default value of 1 CPU and 1 GB of memory. I can create a key pair for login. And I can define what kind of network settings are applied to this instance. So, maybe I want to open it up. That means any kind of communication should be allowed from and to this server. And then I can say, hey, all right, now create my instance, right? And within few seconds, not even minutes, you will get a server. You can log into it and start working on it. So that's the fastest way to create a resource, right? That's the fastest way to create a resource. So console, or I would say manually create a resource. But then what if you have to create 100 different instances? And what if you have to create 100 different instances maybe every week and destroy them at the end of the week because nobody's going to use them on Saturdays and Sundays. So you come back on Monday and create them again, right? So any activity which is manual is not repeatable. I mean, it is repeatable, but the problems with manually repetitive jobs. People lose interest, people make mistakes. Um, there are many challenges. It takes time, right? So it's not repeatable because it is expensive. Manually doing any task repetitively is expensive. If there is something that you do every day or every week and it takes like 2 hours every day, it's better you automate it or use some tool for it so that the computer can do it for you rather than you, right? So manually it is repetitive and it is error prone, creating the infrastructure. So what do? You automate it. How do you automate it? You use a solution called infrastructure as code. And how does that work? It's pretty simple. The team or whoever is responsible for managing the infrastructure, they write a code for infra, right? So it's like a code, but not for software, for an infrastructure. maybe in a YAML format, or maybe in XML or JSON, depending on the tool that you are going to use. So you write your code and then you feed it to a infrastructure as a code tool, maybe Terraform. You can also use cloud provider specific tools. So there are some infrastructure as code tools provided by cloud providers themselves, like AWS provides CloudFormation, Azure provides ARM templates, Google also provides something. Every cloud provider provides some sort of infrastructure as code solution. Generally, teams use Terraform because you can use it for any cloud provider. So you don't have to learn different tools. You can just live with Terraform and use it. So what do? You write your code for infrastructure. In Terraform, it is in a language called HCL, HashiCorp Configuration Language. And you write it, you feed it to Terraform, and Terraform is going to talk to the AWS account or any cloud providers and create the resources for you. Right? So you write the configuration. Maybe you say, I want 5 EC2 instances, 3 databases, 2 subnets, and 1 VPC. Whatever you want to do, you write your desires or the requirements here, give it to Terraform, and Terraform creates those or realizes that requirement for you. Right? Let me show you a demo and then we talk about what is modules. So give me a second. Right. So what we are going to do is we are going to use this existing EC2 instance that I just created. And what I'm going to do is I'm going to show you how we can write a little bit of code and create, let's say, 5 EC2 instances. Right? Let me show you that quickly. Where is our instance? It's here. So let's connect to it. You can now see that I am connecting to the remote instance and I am done. Right? And I'm going to, so now to write a code, I need to, for this code to run, I need to have Terraform installed on that machine. What I'm trying to do is I'm going to install Terraform on that machine, write some code, and then Terraform can create some resources for me. Okay, very quickly. I'm connected here. Let's say Terraform installation Linux. I'll look for a guide. This is the guide. Go for Linux, Ubuntu. I'm just going to run these commands. Straightforward, no special skill required to run these commands. Command number 2, command number 3. And then 4, 5. And this is the final command. Right? So Terraform is installed. If I run the command Terraform, I should get some out. Okay. Now let me write a quick code to create EC2 instances. And Let me quickly get from my notes. Right. So first thing is I need to give the Terraform configuration. And here I need to provide how to connect to my AWS account. Okay. Now I cannot go into much detail because you should understand Terraform already, should be well versed with it. But just to do a quick refresher, we have plugins called providers in Terraform. So whenever Terraform executes to talk to cloud providers, it uses something called as a plugin, which is nothing but provider. Okay, it's a binary. So this is used by Terraform to communicate with the cloud provider. Terraform itself understands this code that we are going to feed it, but it won't understand how to talk to the cloud provider. It takes the help of uh, uh, provider plugin, which is provided by the cloud providers, and then uses it to communicate with the cloud account. So in my code, I'm telling Terraform to use the AWS provider. That means you want to talk to AWS. And then there is this configuration. And in the configuration, we have to specify what region we want to use and how do we want to connect to our AWS account. So I'm going to just input my keys. Okay, let's quickly generate our secret keys. So I'll go to my users. This is my user. This is my security credential, access keys. I hope you guys already know what I'm doing here. So this is my access key. And then I'm going to put my secret key. Now this is sensitive information. So I'm going to stop my screen sharing. And I added my secret key and my access key ID here. And now I'm going to tell Terraform to initialize itself so that it can download the plugin required. It's done. And now I can write my code. That's it. That's all I wanted to do. I can write my code. Sorry. Let's give it a proper name. Virtual machines.tf. And I'm going to define a code which creates 5 EC2 instances for me. Right? Pretty straightforward. I say resource. I want to create a resource, AWS instance. So this is a type of resource. I want to create an AWS instance. And I want to call it EC201. This is the instance type. And this is the AMI ID. So these are my inputs to create AWS instance resource. So create an AWS instance with this particular instance type and this AMI ID. We can give a lot more inputs. For example, what should be the subnet, what should be the availability zone, what could be the static IP if I have static IPs, to which VPC it should connect, and all that stuff. But right now, I'm just going with the minimal inputs, minimal required inputs. So this is it. And if I save it and say Terraform apply, Terraform is going to talk to my AWS account and see if such kind of virtual machine already exists. If it doesn't exist, Terraform is going to say that, hey, no such infrastructure already exists. So I'm going to create this infrastructure. This is the plan, right? Terraform creates this plan and it says this infrastructure will be created and these are the inputs that I have provided. So this is the AMI ID, this is the instance type. The rest of the things about this instance will be known after we finish the apply. I confirm, and this may take some time, maybe 30 seconds. There's a question from Ashish. What is the difference with respect to Terraform if I do the same task using a script to create the infra and to delete the infra using AWS CLI? Yeah, of course, you can do that. You can write your own script. I could have written my own script, but if I started writing my script now, when do you think I would have been ready to create easy to instance? Right? I would take time. It would have to be tested. It would have to be validated. Right? It's a lot of effort to write your own script with complete logic, ensuring that you are compliant with the security guidelines, compliant with the organization guidelines, and then use it. And then you have to maintain it. You have to enhance it, find bugs, fix it. Well, why do you want to do that? Right? So it's a choice. You can do that. You can also create via console. It's a choice that you have to make. Again, question, can we use same Terraform script to create resources over different cloud providers? Unfortunately, no. So if you see the EC2 code, it is specific to AWS. So the syntax remains same, right? You need to define the resource, but if you're creating in Azure, instead of writing AWS instance, you will be writing Azure virtual machine and then passing specific requirements defined by the Azure provider. But the code, the syntax will remain same. So you won't have any problem in understanding if you write code for Azure or AWS. But yeah, same code will not work. Right? I created virtual machine. I can also quickly create more than one virtual machine. So this is one virtual machine. If I just say I want to create more, I can say, create 5 such virtual machines. And you will get 5 EC2 instances. Right? So this is how we do it. Now let's say that we want to set up Jenkins. We want to set up an infrastructure for setting up Jenkins, right? And let's say, I mean, Jenkins for any application, right? For any use case. Let's say that setup requires 3 EC2 instances, right? 2 S3 buckets. And let's say it also requires, what can we create easily? 3 EC2 instances for, let's say, Ubuntu, and two EC2 instances for, let's say, RHEL, and 2 S3 for object storage, and then let's say 1 EC2 with T2 medium Ubuntu. Let's say this is the infrastructure which is required for creating a specific infrastructure for an application, right? This is the specification. And let's say this this infrastructure is required by 10 different teams, right? I have my team, then there are other 9 teams who have to create this infrastructure. But their requirements can, the number of resources may differ. For example, team 1 can have this count of infrastructure. Team 2, they also want EC2s, they also want S3s, same EC2 RHAL, same EC2 Ubuntu, and same EC2 as T2 medium, but they want two such EC2s, five such EC2s, and 10 such EC2s, and six S3s because the team is big, right? So configuration is same, but the counts are differentiating. But then there could be other teams, 3 to 10, who also want similar infrastructure, but then different counts. How do you write Terraform code so that you don't have to write the same code multiple times, right? One option is for each team, write a Terraform code where you say create three, create two S3, create two EC2, create one EC2, and you'll be done. But then you have to write again for team number two with different configurations. So you have to write Terraform code again, and then again and again and again and again, right? So how do you solve this problem? You solve this problem by using modules, right? What are modules? Modules are nothing but shareable Terraform code. So there is Terraform code and there are variables in the Terraform code. So in the Terraform code, I can write one piece of Terraform code and I can say there is a code for, let's change the color a bit. Let's say there is a Terraform code for Ubuntu EC2, right? Let's say there is a Terraform code for S3 bucket. And let's say there is a Terraform code for RHEL. So I can write a piece of Terraform code, right? But I leave everything or most of the things, I use them, the inputs, I use them from variables. So I can say define variables A, B, and C. And in the Terraform code, I'm going to say, AWS resource, Ubuntu EC2, this is the AMI, this is the instance type, but count is equal to A. So whatever is the value of A can be used here, right? And then similarly for S3s, count is equal to B. So what is the value of B can be used here. So similarly, I can make this Terraform code at single place, but I can make it parameterized. Now, what's the benefit of writing code like this? If you write your code like this, then you can share it with other teams like here. See, there are 10 different teams which require similar infrastructure. You can share it with other teams. Let's say team one, they say, hey, use this Terraform code, import code, but they can provide their own value. A is equal to 3, B is equal to 5, C is equal to 7. And team 2, they can also import the code, but then say A is equal to 7, B is equal to 0, C is equal to 3 or 25, whatever. So now by writing one piece of code once, you have make the life of 10 teams easy. They can just use the code and pass their own parameters to get the resources created for their own configurations. Does it make sense? Right? It's like when you import some Python modules or when you import some Go libraries and things like that. It's reusable code. Let me show you an example. Let's write our own module. Okay. I will write a simple infra.df, right? Whatever I like. So I want EC2 instances. So I will write EC2 instances here. The resource name is module EC2, right? Instance type EC2 micro, AMI is this, and count is equal to, let's say, work dot. Give me a second. War dot. I'm going to create a variable, right? So I create a variable, and the value of count is the value of the variable. Right now, there is no value. So if Ubuntu is assigned a value of 5, then count becomes 5, and 5 EC2 instances will be created. And let me create an S3 bucket as well. Something like this. Okay, let's try with this. Pretty simple, pretty straightforward. So this is my Terraform code. Now what I'm going to do is, this Terraform code has to be reused by other teams. I want other teams to create this infrastructure and provide their own parameters. So what I'm going to do is, I'm going to go to my TF code, and I will say in the TF file, I'm going to use the module, right? And then there is a directive called module, right? And I say, let's say, complete infra. Where is the module coming from? So this is a path for the module. This is where my module is right now. It could be a Git path, it could be a network path, it could be a Terraform registry path, whatever. And here I pass my variables. I say Ubuntu is equal to 10. I say use the code from this module and modify the code by passing this variable. So what will happen? Let me show you what will happen. So in the Terraform code now, we have this use module.tf. And if I print the use module.tf, you see it's going to download the source from this. Now what is there? Let's take a look inside this directory. TF module. So it has config.tf, infra.tf. So all the code from this directory will be imported by this use module.tf, right? And then the code will be imported and these variable will be passed to that code. So let's see it working. Terraform init. All right, so give me a second. Maybe I'm mistyping something or I have to use tf was file. Let me see. see, hold on a second. Right. So now you see, I fixed that and it just initialized everything, right? So it initialized the modules, initialized the provider plugin. So now if I see the current directory, you will see there is a directory called .terraform, right? If I go into the directory .terraform, you will see that there is a directory for provider and modules. So in the Terraform directory, Terraform is going to download anything required to run Terraform. So in the providers directory, it will download and keep the provider, like I provided configuration for AWS provider. In the modules directory, it's going to download and keep the module code. If I go to modules, you will see that there is modules.json and it has information about the Terraform module, right? Let's open it. Kind of a single line, but yeah. Okay. All right. So now what I'm going to do is I'm going to say Terraform apply. Hmm. Just give me a second. Let's try something else. Just give me a second. Oh, now I know why I'm making a mistake. Instead of var, I need to give variable. I hope this fixes it. Right. Now let's see. All right, now you see, in my Terraform code, let me get out of this. In my Terraform module, what did I specify? tf-module infra.tf. I specified that there should be EC2 instance created, but how many depends on the variable Ubuntu. And there should be one S3 bucket created. Now, I created this use module.tf, and there I specified that use the tf module, the module which I created, this one, import the tf files from there and pass 10 to the Ubuntu variable, Ubuntu parameter. So that means the 10 came and sit here. So now it's going to create 10 EC2 instances. And if I scroll up, when I did Terraform apply, you can see it's creating AWS instance Ubuntu EC2 from 0 to 9, which is total 10 instances, right? And it also is creating an S3 bucket for us. If I do a Terraform apply and then successfully say yes, it's going to create those 11 resources. And the other team, which wants to, which will use this module, can simply say, hey, well, we are a smaller team, so we just want 3 of these. So now with this, if you do a Terraform apply, it's going to create 3 resources for you. So one code, anybody can just import it and provide their own parameters. Right? So you see here, S3 bucket is created, but from 0 to 2 EC2 instances are created. So that's what module does. Modules provide shareable, shareable and reusable Terraform code. Okay. Now, since it is just 1 hour, so I don't have enough time to show you the intricacies on how you can write a nice Terraform module code and how you can use it multiple times, how you can import it and things like that. But hopefully you got the gist, right? Now, as part of our practitioner course, we cover all these topics in detail, right? So we cover when you see Terraform, we cover all these topics in detail. We cover even Ansible and then complete Docker, Kubernetes. I do take webinars on all these topics, but they are just overview of certain topics. But we have so much time dedicated for all these tools, and we also have hands-on exercises. So we will be working together. I will be giving you exercises, demonstrations, and holding your hand in your practice so that you gain the confidence. So yeah, that's what I wanted to talk to you about today. We are almost on time. So let me open the floor for questions. If you have any questions, please let me know. If you have a feedback to share, you can do that as well. So yeah, open for questions now. Is Azure DevOps a separate course? Do you mean only the DevOps part of Azure or everything plus Azure? I think they have certain course on Azure. I'm really not sure. I'm really not sure. Okay, question from Aman. Can we do same task parallelly on two AWS accounts? You can, right? You can uh, actually initialize two providers with different names, and then you can use. No, hold on a sec. Hold on a sec. No, I don't think so as of now. But yes, you can write a module and then you can import in two Terraform directories where you have configured different accounts. Right? Using the modules, you can achieve that. Any future webinar planned on RPA? I'm really not sure what is RPA, but I'll let the okay, skill upright team respond to this. Another question: how Terraform will know that a module is linked to it? Oh, that is simple. So when you write your Terraform code, right? You specify module, okay? And that's where it knows that, hey, we are referring to a module, not a direct resource. Question, hey, sometimes we need to clear instance cache. So we can do this by using Terraform code instead of doing it manually. What do you mean by cache? Is it an applications cache or what is the cache exactly? And what is the meaning of clear instance cache? So do you reinstall the operating system or you just log into operating system and clear something? Module name is complete infra. How is it access the main TF file? There is no main TF file, right? So when Terraform works, it will load all the files with .tf extensions into memory, all the TF files. You can name your TF files whatever you want, main.tf or abc.tf or test.tf, whatever name you want to give, you can give. It doesn't matter. Terraform is going to import everything. And then it's going to go through all the resources that it has imported from these files. If it sees that there is a module, then it's going to download the code from that module. Did that answer your question? Cool. Okay. All right. I don't see any more questions. So okay, there is one question from Aman. Does Terraform maintain the state? Means can I recover my resources if I manually delete it? It maintains the state, but if you delete any resources on AWS, you can recover it. But if there was any data in those resources, that will be gone, right? So it can create the resource for you, but the data will be lost if there was any in the resource. Okay, so thank you for the questions. Thank you for your time. Do take a look at the course. If you're interested, reach out to Simply Learn team for any questions. And I'm going to see you in the next webinar. Thank you so much and take care. Bye.